Hi everyone, and you are welcome to Liskov Substitution Principle lecture. As usual in this section, I would like to start this lecture by a quick question. We all know that when a class inherits another class, it inherits all the methods that this class has. The question now, can I override one of these methods in a way making the parent class object not replaceable by the child class object? LSP principle has the answer for this question. So without any further ado, let's start our lecture. In this lecture, we will discuss what LSP is. Then we will see a practical use case in order to see how to apply this principle properly in your code design. And finally, I'll end up this lecture by a quick summary. So let's get started. So, what's LSP? Simply, this principle states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program. In other words, when you replace an object from the parent class with an object from one of the child class, the program should work without any problem. In order to satisfy this principle, all the behaviors or methods in the parent class should be applicable in the children classes. Now, to understand this principle in more details, let's move to Jupyter Notebook in order to see a real use case about this principle. Alright, now let's see a real example to understand this principle, which is LSP. I'll assume that I want to build a class that represents a file in the operating system. And from this class, I'll define two classes, which are readable file and writable file. So let's start. First of all, I'll build this example in a way that make these classes violate the concept of LSP. So I will start by defining a class, its name file, and the constructor method init. And usually, we pass to this class two things, the file name or the file path, and the modifier, whether you want to open this file in reading mode or in writing mode. Let's say I'll define inside this class one instance attribute, which is the content of this file, and I will initialize this content by dummy string. Here, I will not open a real file and read the content and so on, because this is not important for understanding this file class. Let's say right now, usually for file, we have two functionalities that we do. We can add data to that file or append new data to this file, or we can read the data from this file. So let's say we have two methods. One, it's named read, which accepts self, and this read simply will just return the content of that file. And let's say that I have another method, which is write, and the work of this write function is to add new content to the file. And here, let's say new content. And usually we do that by say self.content plus equal new content. Alright, now let's define another class for writable file. And in order to do that, all what we have to do is just inheriting this file class. And let's define one method for this writable file class, which is clear file. And here, when we want to clear something from a file, which means I want to reset the content, in this case, into an empty string. Now let me define an object from this writable file simply in the following way. And here, because we have to pass two things, which are the path, I will pass an empty string for this purpose, and let's say r. Let's say here path, just to make sure everything is clear, and run. So I'm able to define an object without any problem. If I say wf.tab, you will see that I have write method, read method, and clear file method, which is expected. So far we have no problem. But let's say, what if I want now to define a read-only file? In this case, I'll define a class, its name readable file, which will inherit file. And let's say if I say just pass for now and come to here and define an object from this readable file, let me just change the order. Okay. If I define an object of readable file in the following way, and I just say rf.tab, you will see that I can read and write. And that doesn't make sense. Why? Because how I can write something into a read-only file? So what to do in this case? One way to do that is simply by come to this class and redefine the write method in this way. Just make it to raise an error, because for readable file, I can't read. If I do something like this, I can guarantee that when I use any object from this readable file class, I can't update the content. But look how much it's weird when I use autocomplete feature and see write method for a readable file. It doesn't make sense. And this also violates the concept of LSP, because right now, not all the methods that are available in the parent class are applicable in the child class. So we see now a real example about how to violate this concept or principle. Now let's see the right way to define your classes without violating this concept. Okay, so let me take this part from my class and let's go to the next empty cell. The solution for this actually, it's quite simple. We know that if we have a writable file, it should be a readable file, because if I should be able to write, I should be able to restore the content and read that content. So let's define, first of all, instead of file, a readable file, or read-only, let's say, read-only file. Okay, and this read-only file should have a method which is read. That's all. Now, when I want to define a writable file, all what I have to do is just define a new class, its name writable file, and now let this class inherit read-only file. And within this class, you can define any method that you want to update the content of this file. So let's say, for example, write, and here let's say self, new content, self.content equal or plus equal new content. Run. Okay, no error. Now let's see what's the difference right now. If I define now an object from a readable file in the following way, or read-only file, let's say here I have to pass the path, and let's say it's for reading. If I say rf dot, now all what I can get access to are the content, which is the instance attribute, and read, which is the instance method. There is no weird names like write, for example, because it doesn't make sense to have write method for a read-only file. Great. So let's now define an object from writable file. And if I say writable file dot tab, you will see now I have access to content, read, and a method which is write. And this write now available only for the writable file class. And by doing so, we see that now we are satisfying the concept of Liskov substitution. Why? Because now all the methods that are available in the parent class applicable for the child class. And that's all. Thank you. We reached to the end of this lecture, so let's recap what we have learned so far. Mainly, in this lecture, LSP principle has been discussed, and we see that this principle states that objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program. So the program should work properly with objects from the parent or from the children classes. Now please refer to the challenges available in the lecture resources in order to practice what you have learned in this lecture. Thank you so much for your time, and if you are available, join me in the next lecture.